Okay, please take it away, Varun.
Okay, thanks, Joanna. Hi. So today we would be talking about the trusted firmware, the testing framework for trusted firmware A. It's just an overview introduction trying to introduce the firmware and the internals. And then hopefully if there is more interest, we can always have more sessions. I'm Varun Wadekar. I represent the Tegra platforms in the upstream community. For those of you who don't know me, I work for NVIDIA and I've been part of the community for quite some time now. I'm one of the maintainers there. All right, so let's get started. These are the topics that we would be looking at today: a general overview of the architecture, what the testing framework is, what it provides us, uh, what platforms are supported, and what it needs uh, for a platform to be enabled in the trusted firmware testing in the testing framework, and what vendors should be doing to enable their platforms. Then we'll look at the different tests and test suites and how to enable, disable them, how to write a test, what are the expectations and all of that stuff. And at the end, we will look at some of the improvement areas that I thought would help improve the overall experience for an end user. If people have more suggestions, we can always add to that list. Right. So as maybe most of you already know, just the testing framework is basically a bare metal test suite, and that runs in it can run in the EL2 or EL1 exception mode on the non-secure side, and it issues SMCs to communicate with the EL3 firmware. Of course, that's the only mechanism, and it has a run to completion model. So it would be as part of your uh, boot chain, and at the end of that boot chain, it will run and it will run its tests. Once all the tests have completed, it will dump the status on your console, and then it will just halt over there. So the advantages with this is that we don't really have to depend on any other environment. For example, I remember at least we used to use Linux in previously, which means we had a dependency on Linux. And after every kernel upgrade, we have to make sure that there are no regressions. And so this testing framework decouples the entire testing methodology from the operating system. So you can write your own tests, and you don't have any dependency there. So just to now dive a little bit deeper, if you look at how the framework is designed, internally we have these building blocks which together make up the firmware. So of course we have the core framework where all the internals of the testing framework lie, the booting structure, and then how they launch each and every test, and how they interact with the tests, and how they mark them present, pass or fail. Of course, to support the framework, you need drivers. So for interrupts and for your consoles, if you have any flash memory, any non-volatile memory that you want to write to, any timers, etc. I mean, whatever your platform requires. So those drivers, of course, you have to implement. Some of them are already present, so you can directly use them. If you have anything vendor specific for your timers or your non-volatile memory, of course, for the UART, if you have any quirks, then you will have to implement them. Uh, on the interrupt side, there are some interrupts that are kept aside by the framework uh, to enable for it to test different features. So out of these, the SGI 0 to 7, it expects them to be available on the platform. It uses it for its internal workings, and then for some other tests. And SGI 7, it expects as the wake IRQ for all the CPU power management tests. And then we have two logging mechanisms. So you can choose to dump your output or your test output, any asserts, anything that you want to the UART, or you can also choose to write it to non-volatile memory. So the logging to non-volatile memory is again configurable. So for platforms which really do not want to write to non-volatile memory. Maybe the driver is not ready at some point when you're starting to port this. Then there is also an option to write to DRAM, and then you can use ways to extract it if that's what you choose to do very early in your development cycle. Okay, yeah, then there are some libraries, of course, I mean for IRQ handling, power management, and some other stuff, which get used by tests. And then the makefiles and XML files, this point is important in a way because uh, so the way to enable any test suite, uh, normally you would just enable the makefile or the C file included, and the test would start to run. But then XML files, we will look at in the later slides. But the XML files basically give you a finer control over out of, so let's say one C file has 10 tests, and then the XML file gives you finer control over those 10 tests, which ones you want to enable or disable, depending on what your platform supports. And then, of course, the platform ports to support all the different platforms, and we have tests under the TFTF test folder. The framework also gives you some test images to support or to test out these different scenarios. So, of course, the test binary is the one that you would flash to your device, and that contains all the tests. To support the firmware update testing, uh, firmware update test suites, then you have the binaries there. And to support the SPM and the SPMM use cases to test them out, you have different payloads that you can install to test them out. Then the last point, the test list.c. So this is a build artifact that gets generated at the end of the build and depends on what you have enabled in your makefiles and XML files. So this is an output file that gets generated by a Perl script, and you can treat that as your test database. So at the end of your compilation, you can always look at this file and see, what has been enabled, what has been disabled. Does the list look right to you? And then you can tweak it if you want. At any point, if anybody has any questions, just interrupt me, let me know. Okay, so moving on. Yeah, so I mean, this is an interesting slide for everybody. We would like to know what tests are supported. So I've tried to capture the list of the tests. This is as of 1 week ago. Hopefully this list is still valid, or maybe if there are more tests, then it should be an incremental addition. But right, but if you look at the overall test suites, then you have test suites for, in general, framework validation. So this is the initial test suite that you'd enable for your platform to make sure that the other tests that you would run, for example, PSCI or performance or any other SDEI, they would really depend on the framework validation tests to complete. So the framework validation makes sure that your timer is working, your IRQ handling is working, your CPU on, CPU off. So all the basic blocks that would be required for the subsequent tests, they are working. So this would be the first step for any platform when they start to port it to their platforms and start testing. And then on top of it, you can enable, depending on what you want to do, uh, all the runtime services, PSCI, SDEI, and whatnot can be tested with the runtime services test suite. Then you can also test out all the CPU extensions that are supported by the architecture, as we talked about the firmware update, and then there are these other test suite for performance and some other tests in the miscellaneous test suite. If we look at the list on the right now, the first black box, it contains all the test suites that are supported. On the right, I've tried to provide a show, internally for the standard test suite, what all gets executed. So whenever a platform would start to port the framework, the initial step would be the framework validation, and then you would either go for the standard test suite, which contains a lot of tests, and most of these tests are included in the standard test suite. So if you do not select anything during your build process, then the standard test suite is the one that executes, and that's why I wanted to show here on the right what exactly gets executed in the standard test suite. There are also extensive tests that you can run. These are the long running tests, or they really test out your platform to its limit. So that is something that you can do after you know that the standard test suite is running. Okay, so if you look at the platforms that are available today, as of today morning, so we have all these ARM platforms, and we have one platform from High Silicon, and then we have these three NVIDIA platforms that are supported. Right. So next, I would like to talk about what it would take for a platform to get the framework running on their system. So of course, we talked about the drivers that you would have to implement, and if you have to implement the console, or you can also use non-volatile memory. It depends on you. But if you want to use the console, then we do support two UART drivers. If you have anything else, then you will have to add your own driver there. And then the power domain tree would talk about how your power domain structure looks like, how many nodes you have, and then how should the TFTF framework power them off. So that information would be in your power domain tree. And if you have any physical to logical CPU numbering or conversion, something specific to your platform, then that is something that you will have to implement. And then there are other defines similar to trusted firmware A or M stack. We have all these different defines to better describe your platform needs. So all of that goes in your defines in the platform def.h. And then the last item is we talked about the XML files and make file, but there is another file which resides in your platform. So it's a text file, basically, which gets built, which gets picked up during the compilation process. And here you can list down the tests that you want to skip during the makefile process, and you don't want to run them for any reason. Maybe the test is not supported, or during your initial development, you see that the test hangs and crashes, and you would like to debug them later. So that list can be provided here. It's optional. If everything is passing, you don't choose to use this text file, that's okay. All right. So now, once you have everything running on your platform, you have the port. It's booting up, and you have to write new tests. So how would you go about it? So the test prologue is how the function for your test should look like, and this is the main entry function that runs on the boot CPU. It would run to completion, and then it returns whatever the status is to your framework. So for some reason, if you think that the test has passed, failed, or if you also decide to return it as skipped. So these three statuses are supported by the framework. You can return them to the framework, and then accordingly, the framework will keep account of all these tests. And if you so for looking at the build process, you can choose to use all the existing tests. So for that, you just include the make files that are there, and you can be done. And then on top of it, if you want final control, we talked about the XML files that you can use to get a final control. And finally, you will generate the test binary and then just flash it to your board. If you want, when you get started, the sample tests or the skeleton tests are under these folders, so you can use that as your as your as your baseline and start developing on top of it. Okay, so let's say you want to enable or disable any of the current tests. I mean, we talked about it. I just wanted to get into more detail here. So the first point shows you how to compile, how you would go about compiling it. I mean, this is standard command line from even from the TFA side. One additional parameter is the tests parameter. Here, you would have to specify which test suite you want to compile. So let's say you want to just test the PSCI or only the validation, then that would go over here, and then the test would pick up the corresponding make file. So the name here should match the make file, so that the build structure understands which makefile to look for. So, okay, so you have done that and you figure out that, some tests need to be disabled. So how do I do that? So for your platform, you will have this text file. It's called as tests to skip. And there uh, you can specify, which tests or which test suites as completely that you would like to disable. So if you look at the first line in the black box, here inside the PSCI system suspend validation test suite, I would like to disable the system suspend from all course tests for some reason. So you have that control here. Or if you look at the last line, maybe you don't want to support the entire test suite. So boot requirement tests is a group of tests that you would not want to support. So you just add that to your text file, and then the build process understands that you want to skip this. So it does not compile them in your final test list.c and your final image. Okay, so now we've talked about all the features and everything that the framework provides us. But from my experience, I think we can improve certain parts of it. We can add more features. So I believe if we can add position independent execution to the test. Right now they expect a specific base address, so that can be improved. And as I said, the test suite runs to completion, so we don't have an interactive shell. So folks who have worked on the U-boot side, if when that payload boots up, then you get a command line, and you can have different commands. So something similar here, where after the test suite boots up, you have an interactive shell, and then you can interact with the testing framework, and you can ask it to do some stuff that you would like to test, or you might want to interact with your platform. So an interactive shell might help. Another aspect of the framework that I think can help is if we can have dynamically, if we can have tests that can be dynamically installed to the device. So instead of having to compile the test suite every time, if you already have them, all the tests built, and you can just install one test and get it to run, that would be a great feature addition, I think. And of course, we can always keep on adding more tests and more platform as we go along. So yeah, we are getting to the end here. I just wanted to talk about some references here that people can refer when they start developing. I mean, the documentation here is great, and you can go through everything. Whatever I talked about, it was just a starting point, and you can use these references for developing your tests. So yeah, we are at the end. I would like to especially thanks Madhukar and Joanna from ARM. They helped me during the initial development of this slide deck, provided feedback. So thanks a lot to both of you. And I'm no expert. I've just tried to uh, present whatever I know. So there are other experts here, and if I have if something doesn't seem right, just let me know. Or now we can open up for questions, feedback, comments.
Hey Varun, just quick question, right? So in the improvement slide, you said position independent code, right? So are you talking about position independent code for the framework itself?
Right. So yeah. So right now we bake in the base address in the make files. So if you can remove that dependency so that you can load it at any address that you deem fit, that would be a good improvement.
That's just to reduce the platform dependency. So you just build the same TF-TF image and load it for all platforms. Something like that.
Or maybe even on your platform, if your base address keeps on changing all the time for any reason, you don't have to
Oh, I
compile
see.
you don't have to
Okay, yeah.
compile it all the time and then flash it with a new address. You can keep on using the same binary.
Okay, understood. Thanks.
Yeah, it would be great if we reach a point where one binary works across all platforms. Maybe we can add that to improvement areas.
Hey Varun,
Thanks.
hey Varun, can you go to the slides with the number of tests?
Sure. This one?
Yeah, this one. Yeah.
Yeah.
So just curious how what does SPMM really test? SPMM-MM. What test does it test? Like how does it test?
So from my limited experience, what it does is it interacts, tries to, so it has its own payloads that I talked about earlier, that they install in the SEL1 space, and then the SPMM just tries to make sure that the communication to that payload works. I don't think it's a full-fledged SPMM use case, but at least some initial communication works to the payload, and then I think there are also some communicate tests that run there. But yeah, as I said, I'm no expert. This is just from my initial reading of each and every uh, test suite.
Okay. So there's okay. So you're saying that the non-secure world communication, like the SMC from the non-secure world, may also be
Right.
present there.
Right. Yeah.
Okay. Okay. And so this is also pre-FFA, right? PSA-FFA framework.
That's right. That's right.
Okay.
There are some tests for FFA also that are present in the
If you
framework
go to,
as of
if
today.
you see anything related with FFA, just at the bottom, there are 4 or 5 of them.
Sorry, I couldn't.
PSA, FFA, direct messaging, PSA, FFA person.
Right.
Sorry,
Right.
can you be please a little louder? Sorry, I didn't catch that. Yeah.
So the test at the bottom of the list, if you see, there are 4 or 5 PSA related tests.
Oh, okay, on the right hand side. Okay, got you.
Yes, yes.
Okay. Oh, okay, yeah. There are a few of them. Yeah. Thanks.
Yeah. This is what we have today, and of course, this list will keep on increasing. So yeah, if you have anything that you would like to add, please upstream.
Sure.
Yes, we had a lot of partners, of course, contributing to the TFA main repository, but this has been, I think it's about a year and a half now, if not longer. The TFA tests is a sister repository, and I know Varun, who's got familiar with the test suite by adding the NVIDIA Tegra platform to it, so and upstream that support. So please, if this is valuable to you when you do your main TFA repository changes, think about this test as well, and contribute anything. The same with all those improvements. I mean, there's, as with a lot of projects, there's lots of things that could be done to improve them, and being open sourced and upstreamed, more than willing to work with the community to make this a better functional test suite.
Just one thing regarding this way of improvement. So correct me if I'm wrong, but today TFA test is only limited to ARM64 platform, right?
Someone from the ARM side wants to address that. I don't remember.
No,
I think
Arch32
no?
is also no. Arch32
Yeah.
is also supported.
Looking to the payload entry points, it seems that it's really linked to ARM64 regarding register things on all the stuff. So that's why I'm a little bit surprised.
No, it's not correct. You can run, you can configure tests and configure the platform to run in Arch32 mode, like for
Okay.
FVP. And we've got some CI configurations for doing this.
Okay, so I will look further for that. Thanks.
Okay. And Varun, it's Alexei here. Can I ask you a question?
Sure, go ahead.
So you mentioned that the test results can be stored in non-volatile memory and SDRAM. So how would you access these results in this case? Do you need external debugger to be connected to the platform in this case?
I suppose so. Yeah. If you do not have UART, or if you're trying it on a field device somewhere, you don't have that, then yeah, it would be stored on your non-volatile memory, or in DRAM, and then yeah, I mean it depends on how your platform provides you the capability to go and read that. Maybe JTAG is one way, or if there are other ways to get to that store, then might be platform specific.
Okay. Yeah, thanks. And also there was a slide which was listing all the ARM platforms which are supported. Can you go to the slide? Yeah, so actually there are much more platforms supported. So all FVP platforms, and I think there is a document in Trusted Firmware
Right.
which specifies all the platforms which are supported. And I think the list is greater than this.
Sure. Yeah. My apologies. It's a mistake on my part.
Okay. Yeah. Thanks.
Yeah, Varun, Manish here.
Hey.
Regarding that improvement slide at the end,
Yes.
just go there. Yeah, so in that dynamic installation of the test, you mean like module load, module unload kind of things we used to do in the Linux environment. Like that's what your intent over here. We can create
Yes.
a module and okay.
Yeah.
So it's like
That can be one way. Yeah. Basically, yeah. I mean, module load, module unload can be one way. I mean, my intention here was some mechanism where you have pre-built tests that you can install onto the device and get them to execute.
okay.
Yeah. I mean, after this is during runtime, not having to compile everything all the time.
No, I was thinking like we just start the init script and just get the shell, and then whatever the test you want to run, we can run it. Depend upon you can load the module and then get that test inside the inside the file system, and then you can run it. So individually you can run each and every test, depend upon your choice.
Yes.
Okay. Yeah. Thanks.
Thank you.
Hi, Varun. This is Madhukar.
Hey.
Sorry, go ahead. Someone else was talking.
No, sorry, you go ahead.
Yeah, I just had one question. In one of the first slides, you mentioned that we can run the TFTF image in EL1 mode, but I was just confused about that part. I was under the assumption that all the tests done in EL2 non-secure.
Yeah, from my understanding, it supports both. You can either run in EL2 or EL1.
Okay. Did you happen to see any such test running in EL1 mode?
Not on the platforms that we have at NVIDIA. So we support. I mean, I run all the tests from EL2.
Okay. Thank you.
Hi there. Very good presentation. Thanks for that.
Thanks.
I had a couple of questions. So I'll start with output of the test. So, we talked about, pushing the results onto RAM, but UART, I guess, is not a regular or the default option. Is that correct? Because EL3 itself might be outputting stuff to UART, which we might want to look at.
Yeah, I mean, if you are sharing the same UART, then yes, you might see interleaved messages from both of them. But if you have different UARTs, then you can always jump to different UARTs. And of course, if you don't have any UART, then you go right to non-volatile memory and then read it back from there. So for the DRAM, I would like to add the initial memory during configuration. When you compile the TFTF, you can provide the base address of your DRAM that can be used instead of the non-volatile memory. So that can be a separate chunk in the DRAM that you specifically reserve for this, and it's a built-in setting. So so the framework uses that to write all the output.
Understood. The other question is this firmware which runs in EL2, is it derived from something like LK or something like that, or is it written ground up?
You mean is the framework itself derived from some other software, and then or is it written from scratch? Is that your question?
Yeah, that's the question.
Yeah. I think someone from the ARM side will have to answer that.
Yeah, I probably think it has been derived from scratch.
Yeah, I
it
think
has been developed from scratch, not derived from any other project. Though we use many of the libraries and other things from our original try to keep those libraries in sync.
Got it.
You're
Thank
very
you.
faint, Manish, sorry.
What?
You were very faint. I'm not sure if everyone heard your answer. I know I didn't.
Okay, so it was developed from scratch, and the common libraries between TFA project and TFA test, we keep them same, and also the assembly files, they have been taken from TF project.
Got it. A final question: is there support for EL1 official? Is it officially supported? Is it widely used, or do mostly people use EL2? Because I also heard that initially I thought it was only EL2. The question is also with regards to testing for hypervisors. If somebody has a hypervisor, can this framework be used or extended to support hypervisor testing as well?
So for to answer your first question, I mean, at least on the NVIDIA side, we install it in the EL2. So if other platform owners have run this in EL1, they can talk about their experience. But on the second, for the second question, I presume it should be possible. I mean, your hypervisor would, of course, have some control on what SMCs get routed to EL3. So I think on the hypervisor side, you might need some handshake or some configuration to support TFTF. But other than that, I think should just, I mean, it's similar to running it in EL2. I don't see anything extra that you might have to do.
So
Okay.
is the idea that you want to run it in EL1 as a VM? You want to run TFTF as a VM in EL1?
Either as a VM or, yeah, probably as like a primary VM, which can then invoke hypervisor calls to test the hypervisor. I don't want to do it like right now, but it's an idea. I'm just thinking about it. So, and then also, test EL3. So yeah, but if it is an EL2, then obviously that would be tricky. It won't be possible.
Right. I think we can add this to our, the improvement area slide and maybe take that feature development in the future.
So
Yeah.
can you guys hear me clearly now? Hello?
Yeah.
Can you hear me?
Yes.
Yeah. So on the similar lines, for FFA tests, what we do is we have, there are some payloads like Cactus. They are running at secure EL1. So though in secure world, there is no primary VM concept. All of the VMs are like secondary only. So what we do is at non-secure EL2, we have TFTF, and we build Cactus images for running at secure EL1s. So you can look at those. So this is a different binary altogether. The Cactus binaries are built separately from the framework binary, which we then load into different as a different VMs.
I see. Okay, that helps. Thank you.
Right. And to build that Cactus binary, there would be just an additional parameter at the end here. So in addition to TFTF, you can at the end you can add whatever you want to compile. So let's say if you want to compile one of those payloads, so you type TFTF space Cactus, and then it will compile for both of them.
Got it. Thank you.
Yeah.
Do you use these as part of continuous tests? Do you run these tests as like pre-submit or continuous testing?
Yeah.
Yes.
Right.
Yeah, this might be an opportunity to talk about a lot of the tests that people see being run as part of patch submissions. Makes use of TFTF or TFA tests, as it's now called. And a lot of these tests are being ported to be run as something called the Open CI, which I probably owe another session on that at some point in the future, which is where we're moving all the tests that we run internally in ARM and on everybody's patches to be run in the open on trustedfirmware.org servers, and you'll be able to see the results more directly. At the moment, they're a little bit hidden because they're behind ARM's firewall, but that is something that's coming in the next few weeks, I think, or at the first phase of this OpenCI. Once it's reached a little bit more maturity and conclusions, I intend to make a Trusted Firmware tech forum session on the OpenCI, and you'll be able to know a little bit more about how some of these tests and other tests that we have been enabled to be running in the open as part of the patch submission. And on a, we have an internal in ARM, we have something called a daily test CI. So as well as on patch submissions, the tests being run, we run the tests on the repository to ensure that that no breakages have crept in. But that's probably a subject for a different tech forum, but I thought I'll just mention it here.
Yeah, sorry if I missed it, but can we specify the number of cores on which this test can be run?
Yeah, so when you say number of cores, as in, so I mean, the test suite runs on the boot CPU itself. And then as part of the PSCI test or some other tests, you can always power on, power off the secondary cores. And then if you want, you can also run something on those secondary cores. Yeah, so I don't know if that answers your question, but this is what the framework provides.
Okay, what I was asking is, in some systems, there could be support developed only for core 0, and then you might want to specify just run it on core 0, even the PSCI stuff, a PSCI test. So that's what I was trying to ask, if you can specify the number of cores you can run into.
I'm not sure I understand, because I mean, PSCI would run on all cores, so that way it is configurable. You can run it on the boot CPU also, and you can run also on the secondary CPUs if you want to.
Yeah, but what about the other test?
Oh, okay.
Yeah.
Okay, so you mean all the test suites or the tests that are running on the boot CPU, you also want to run on all the other CPUs?
Yeah, I mean, can you specify the number of core you want to specify? Just limit it to 1 core. Yeah, that's what I'm kind of curious. Yeah.
Oh yeah, you can limit it to 1 core if you want.
Okay.
But right now, I don't think we support running the entire test suite parallelly on all different cores, because there are some tests which require other cores to come online, go offline. So because some part of it runs on the other core. So, but if we run the entire test suite on all the cores at the same time, I don't think that would work.
Okay.
In Mayur, to answer your question, if you can, I think the hooks are present in TFTF for you to be able to run any test on any core. I don't believe it's being done today, but yeah, I think the PSCI hooks are there for you to run any test on any core, if that's what you're asking.
Yeah, I mean, that was part of the question, but thanks. I think so. I got my answer. Yeah, thanks, guys.
So sorry, I just wanted to say, if there are no questions, then I think yeah, Joanna, I'd like to hand over to you.
Yeah, sure. If you stop sharing, I'll go back to one of my screens and we can.
Yeah.
Thank you. Bear with me. Share screen. Let's get that out of the way. So, so we're at the point now in our presentation or in the session. So we've covered the Varun's session. So thank you for that, Varun. And we're now at the point, and we've got about 15 minutes if we want to use this to talk about anything from the mailing list that we've covered over the last 2 weeks. So I think I've got the November mailing list here. If there's anything in this particular space that folks want to talk about, as well as anything that people want to talk about from the back end of October. So is there any subjects people wanted to follow up on?
Again, not from me. Just I have a question, actually, testing question. Maybe Varun or somebody else from Mom can answer this, but you know, there was a discussion of fuzzing, and we had a presentation as well. Are there any plans for incorporating fuzzing into TFTF? Or will it be based on TFTF, or will
you were cracking your audio's cracking up a little bit there, but I think your question was: is there any fuzz testing available as part of the TFA tests tools? Not as part of TFA.
Yeah. What are the,
sorry, I didn't catch.
I'm sorry. The voice is breaking.
Sorry, was that the question?
What I was asking is that I was asking that we had discussion of SMC fuzzing. Is the plan to incorporate that into TFTF, or will that be a completely different setup for SMC fuzzing?
Do you, Mark, are you on the line? Do you want to talk about the plans for the fuzz tester?
Yeah, so right now we have incorporated a basic fuzzing mechanism for fuzzing SMC calls. So it's based upon essentially a creation of a bias tree. So you have various types of SMC calls you would declare with the biases of certain types, and you would categorize them based upon the logic of the testing you would like to do. And that has recently been merged. So we have that level of fuzzing capability now, but it's not been extensively employed yet. So it does exist. It's just we still have yet to devise the strategy for its employment just at this stage. But yes, it's there. Does that make sense?
Yeah, it does. I think my voice is break, so I can't specify the question correctly. But I was asking is that testing, fuzz testing, does that use the same framework that Varun was describing, or does it use a different framework?
It's using the same essential framework to conduct the SMC calls as you would inside an actual directed test that's presently resides within TFTF. So it's a directed test where you do a series of SMC calls, and that's the same type of methodology we would employ for the calls for the fuzzing. It's all takes place from the point of view of the SMC. So you could take all the directed tests that we would have in the repository that exists today, all the SMC calls there, and essentially randomize them and create a fuzz scenario for that. All you'd have to do is create a bias tree to do it. So yes, I think that answers does that answer your question? Or it's an approximation of what the directed tests do today.
Yeah, that's good enough. Thanks.
Okay.
Yeah, so the fuzz tester will be incorporated as part of the OpenCI, and as well as TFTF tested on different platforms, or the ones that are listed by Varun. Various models, ARM models have all been provided as part of the OpenCI, so those runs are going to be done in the open. So if you can imagine the TFTF is a list of tests, and then as part of the CI, a combination of build options and targeted platforms are then used to do instances of those runs, and then in addition to that, Mark's newly upstreamed fuzz tester will also be run as part of the OpenCI.
Thank you.
Any other questions? Anything? Otherwise, I'll let you all go 10 minutes early. So just to put a plug, as I said, for future, there'll be a session about the OpenCI once it's matured a little bit more and a bit more visible to people in the project. It's being worked on at the moment, and I hope it's going to be delivered sometime in November, or the first instance of it. It'll be something that will be incrementally improved over time. And there's other technologies that we have related to testing. You know, we've got a code coverage technology. I don't think we've presented that here yet at the Tech Forum, but that might be a useful, interesting session for folks. I'll go and reach out to some folks internal in ARM who've put this together. I think the technology now has been upstreamed on GitHub of how to do code coverage on ARM platforms for firmware, which I'm sure will be interesting to folks. And we're using that technology to try and find gaps where we can improve tests by writing more tests for things for TFTF or the unit test framework, which has been presented in a previous Tech Forum. And of course, Mark's fuzzer, all of these are types of testing that we do. Varun has shown you how TFTF is set up and how a more sort of functional led set of tests can be run. But we appreciate a lot of tests can't, not one type of test framework or test type is good for everything. So testing is and validation is an important thing that we're interested in the project. Part of which is why we're doing the OpenCI, to make what testing is done a lot more visible to the contributors. With the goal, of course, to get you contributors to help improve things. But anyway, more sessions for the future around more of the test capabilities coming. Anyway, that's my little plug on testing. If there's nothing else, I'll let everybody go, and thank you for attending this week's Tech Forum.
All right, thanks. Bye.
Thanks, guys.
Bye.
Thank you.
Thanks, bye.
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 Thank you. Bye.
Bye.